While reviewing recent pull requests, I noticed a growing number of repositories that no longer contain handcrafted JSON parsers for GPT responses. Instead, developers are relying on OpenAI's function calling feature to let the model invoke a predefined function and return typed arguments directly. This shift is visible in open-source projects that integrate chat assistants, where the codebase now includes a small schema definition rather than extensive prompt engineering to coax structured output. The observation suggests that function calling is already reshaping how developers design the interface between language models and their own services. The pattern appears across languages, from Python scripts that wrap the OpenAI client to TypeScript services exposing a thin HTTP layer. Delegating formatting to the model reduces parsing errors and speeds iteration, especially as data models change. OpenAI's function calling API extends the standard chat completion endpoint with an optional functions parameter. Developers supply a JSON schema that describes the name, description, and parameter types of each callable function. When generating a response, the model can either produce a normal text message or emit a function call object containing the selected function name and a JSON-encoded argument list that conforms to the schema. The feature was announced in June 2023 and is currently supported by GPT-4 Turbo Preview and GPT-3.5 Turbo 0613 OpenAI API Documentation 2023. Unlike prompting the model to output raw JSON, the function call is validated by the API before it is returned, which reduces the need for post-processing heuristics. The core of function calling is a three-step loop. First, the developer sends a chat request that includes the function schemas alongside the user's prompt. Second, the model evaluates the conversation and, if it determines that a function can satisfy the user's intent, it returns a function message instead of plain text. The message contains the function name and a JSON-encoded argument object that matches the declared parameters. Third, the client code parses this object, executes the corresponding backend routine such as a database query, an API call, or a calculation and feeds the result back into the conversation as a new assistant message. This pattern lets the LLM act as a natural language orchestrator while the actual logic remains in trusted code, reducing hallucination risk for critical operations. One practical insight is that function calling eliminates much of the trial and error that developers previously spent on prompt engineering to force JSON output. The schema validation happens server-side, so malformed arguments are rejected before any downstream call. A second point is that the approach naturally enforces a contract between the model and the application, making versioning and testing clearer. Changing a parameter type or adding a new function requires only an updated schema, not a rewrite of prompt heuristics. Finally, developers must still treat the argument payload as untrusted input. While the API checks syntax, it cannot guarantee semantic safety, so input validation and rate limiting remain essential safeguards. In summary, OpenAI function calling API reshapes developer workflows by moving the responsibility for data formatting from the model to a declarative schema, and by positioning the LLM as a coordinator that triggers real code rather than generating raw text. This leads to more reliable integrations, clearer contracts, and faster iteration, especially for tasks like database queries, external API orchestration, or on-device calculations. However, teams must still implement robust validation, monitor usage, and keep schemas in sync with backend changes to avoid subtle bugs. If you found this analysis useful, consider subscribing to the Latent Dispatch for regular, source bucket updates on emerging AI tooling and practices.